in case 2, the denominator is still a product of linear factors, but now one or more of those factors are repeated. Okay, so in this case, it says suppose the complete factorization of q of x, which remember is the denominator of your original fraction, contains the linear factor ax plus b repeated k many times. That is ax plus b, that quantity raised to the k power, is a factor of q of x. Then, corresponding to each such factor, the partial fraction decomposition for the fraction p of x over q of x is going to contain this. Okay, so what you see right here. Okay, so what's going on here? Okay, we still look at the denominator. When we factor it, all the factors are linear. So each individual factor, the highest power of x is the first power. However, you are going to see a repeated factor somewhere. Okay, so for example, you might see an x plus 1 in the denominator, but then there will be a second one. Keep that in mind. You can write it this way, x plus 1 squared. Okay, so if you see this is a linear factor inside the parentheses, we have something linear. It is squared. That is indicating a repeated factor. You're going to see that x plus 1 is a factor 2 times. Okay, same thing if we saw x plus 1 cubed. Okay, this is the same thing as x plus 1 times x plus 1 plus x times x plus 1. We still have a linear factor on the inside. X plus 1, x is raised to the first power. It's repeated 3 times. Okay, please make sure you see the difference between this and x cubed plus 1. Okay, these are not the same thing. This that I'm underlining, the x cubed plus 1, that is not a linear factor. Okay, so you've got to understand the difference here and pay attention to what is being raised to the power. Okay, so what's going to happen is you're going to go about your setting up your fractions like you would in case 1. The difference now is when you see this repeated factor, you're going to put it in the denominator multiple times. Okay, so let's say we went, I don't know, we had ax plus b is our repeated factor. Let's say it goes to the 4th power. Okay, it's repeated 4 times. You would have one fraction with the denominator just ax plus b to the 1st power. Then your second fraction is going to be ax plus b squared. You're going to bump it up a power. The third fraction will be ax plus b cubed in the denominator. And you're going to keep doing this until you get to the highest power. So the last fraction pertaining to this factor would have a denominator of ax plus b all to the 4th power. Okay, that's when you stop. Okay, because each one of these, because the factor itself is still linear, you're still going to go down a degree in the numerator, so you will still have just numbers. Okay, and they all do need to be distinct. Okay, so that's how you're going to handle this situation. Okay, so let's look at example 2. Find the partial fraction decomposition for the given rational expression. 2x over x plus 1 times x plus 2 quantity squared. Okay, first thing I need you to realize that the degree of the numerator is 1 because you have 2x, x is raised to the 1st power. The degree of the bottom, in the bottom we have x plus 1 times x plus 2. The x plus 2 is squared, so it's multiplied by itself. So if you were to multiply this out, this would be, the first term would be x times x times x. That would be an x cubed. So the bottom is degree 3. Okay, so we still have a situation where the degree of the numerator is less than the degree of the denominator. So it's going to be one of the 4 cases. Okay, like I said, everything's going to be mixed up on your homework or the exam or a quiz. You've got to be able to figure out which case you're dealing with. Okay, again, because the degree of the numerator is less than the degree of the denominator, it's one of the 4 cases. You just have to figure out which case it is. Okay, all right, so what I'm going to do here, okay, when I start looking at this, the denominator here is factored. Okay, when we did example 1, the denominator was not factored. You know, sometimes you're going to be given the denominator factored, sometimes you won't. Okay, but here it's fully factored. If it had not been, you would need to start by factoring the denominator. Okay, all right, so I can go ahead and start. Okay, this is 2x over x plus 1 times x plus 2 squared. Okay, this is the same thing as, I'm going to write out all my factors here. This is the same thing as 2x over x plus 1 times x plus 2, and then the x plus 2 is squared, so it needs to be multiplied by itself. Okay, again, if you look at these individual factors, we have x plus 1. That's linear. The highest power of x is 1. And then x plus 2 is a linear factor. The highest power of x is 1, but it's repeated because we see that linear factor twice in the bottom. Okay, so this is case 2 where you have linear factors, but one or more of the factors are repeated. Okay, so this is how you're going to go about setting it up. Okay, we are again trying to write this original fraction as the sum or difference of simpler fractions. Okay, to set up the partial fraction decomposition, we first have to deal with the factor x plus 1, the guy in yellow. Okay, it is not repeated. Okay, so we only need one fraction for this guy. Okay, in the numerator, we're going to go down a degree. The denominator is degree 1, so we're going to go down a degree to degree 0. That's just a number. Okay, so that's going to handle that guy. Okay, then we're going to go on to the x plus 2 factor. Okay, it's repeated. Okay, so what you have to do is put it, and when we look at it, it's raised to the second power. So you're going to, because it's the second power, you're going to see 2 fractions for x plus 2. Okay, in the first fraction, it will be raised to the first power. Okay, which you don't have to, show that it's raised to the first power. Just know it's going to be raised to the first power. Okay, and then in the second fraction for it, it's going to be raised to the second power. Okay, so it's going to look like that. Okay, if it had been raised to the third power, you would need another fraction. You would write this one, and then you would have a third fraction for x plus 2. It would be raised, the denominator, you would have it raised to the third power. Okay, so you just keep going until you break them down individually, and you keep going until you get to the final power. Okay, now what's important here? Okay, the factor here is still x plus 2. Okay, inside the parentheses, that's the factor. It's still linear. So in the numerator, you still go down a power. So we need a number, degree 0, in the numerators. Okay, again, we cannot go into this thinking that all the constants a, b, and c are going to be the same. So we have to use different letters here. Okay, but this is how you set it up. Okay, and now we're going to go through the process again of just solving for the a, the b, and the c, and then we will have our partial fraction decomposition. Okay, again, like I said, the hardest part is setting it up. Okay, then you just, get rid of the fractions, turn it into a system of equations, and solve the system of equations. Okay, all right, so let's go ahead and take a look at this. What I'm going to do now is I'm going to try to get rid of the fractions. So I'm going to start with this middle fraction. So 2x over x plus 1 times x plus 2 times x plus 2. And I am going to give myself some room here. I'm just going to write out what we have, but kind of spread it out. Okay, so this is what we have here. All right, if we want to get rid of the fractions, okay, we are going to have to multiply this quantity on the left by the entire denominator. So I'm going to have to multiply by x plus 1 times x plus 2 times x plus 2. Okay, if I do it to the left side, I have to do it to the entire right side. That means everything is going to get multiplied by this x plus 1 times x plus 2 times x plus 2. Okay, so I'm just going to write this out. You can't just multiply one piece of it. You've got to be consistent to keep your equation balanced. You've got to multiply everything by this quantity. And I'm out of room. Oh, no, I'm not out of room. I think I can. Nope, can't fit it. Okay, so I'll just put it like that. Okay, so now let's clean it up because things should go away. The fraction should go away. On the left side, okay, x plus 1 cancels with x plus 1. X plus 2 cancels with x plus 2. X plus 2 cancels with x plus 2. Okay, we are simply left with 2x. Okay, that's got to equal, for this on the other side of the equation, okay, we've got an x plus 1 in the bottom. It's going to cancel with this one. So I am left with a times the entire quantity x plus 2 times x plus 2. I'm going to keep the plus sign in the middle, okay, for the b part, okay. The x plus 2, you have one of them canceling with one in the top, okay, so you're going to be left with b times x plus 1 times x plus 2, okay. You still have another plus sign, okay. On the c part, okay, the bottom is x plus 2 squared, so that's really x plus 2 times x plus 2. So this will cancel with both of these x plus 2's, and we are left with c times the quantity x plus 1. Okay, fractions are gone. Okay, this is the information we have to go on to solve for a, b, and c. Okay, follow your instincts. We are going to multiply all this stuff out. Okay, we simply have a 2x on the left. Okay, I am going to leave the a out front, and then I'm going to multiply out, I'm going to FOIL out the x plus 2 times x plus 2. This is going to be x squared. This is going to be 2x. And then if I do the inner terms, I will get another 2x. And then the last terms will give us plus 4. Okay, then I'll move on to the b part. I'm going to leave the plus b, leave the b out front. I'm going to multiply out these other guys. Okay, so FOIL it out. I'm going to get x squared plus 2x plus 1x plus 2. Okay, then I'm going to have the plus c. Okay, we can go ahead and multiply out the c because that's easy. This is going to be cx plus c if you distribute here. Okay, so let's keep going. Okay, so we are going to have, we're going to send the a through, we're going to send the b through, and we're going to combine like terms. Okay, let me combine terms first. This is going to be x squared plus 4x plus 4. That's what a is being multiplied by. B is being multiplied by x squared plus 3x plus 2. And now I'll go ahead and send the a, b, and c, or sorry, the a and b through. This is going to be ax squared plus a, well, let me do it this way. I'm going to do 4a times x plus 4a plus b times x squared plus 3 times b times x plus 2b plus cx plus c. Okay? If you notice when you scan this, some of the terms are quadratic. You see an x squared. Okay? Some of the terms just have an x, and some of the terms are just numbers. Okay? We need to combine like terms, okay, on the right, because on the left, we're going to equate. If you notice on the left, we don't have an x squared term. We don't have a constant term. We just have an x term. So we're going to equate with this, with what's going on the left side. Okay, so I'm going to leave the left side alone for right now. Okay, I am going to combine like terms. Okay, so I'm going to find everything with an x squared. Okay, I can combine these. They are like terms. Okay, so I'm going to go ahead and factor out the x squared, or you can also look at it if you're combining like terms, just add the numbers in front. I have a many x squareds and then I have b many x squareds, so I have a total of a plus b many x squareds. Okay, and then I'm going to look for anything that has just an x, so I'm going to highlight these guys in blue. Okay, so again, you want to add the numbers in front. I have 4a many x's, then I have 3b many x's, and then I have c many x's. Okay, so I have a total of 4a plus 3b plus c many x's. Okay, and all these terms are positive. Okay, so I'm adding here. Okay, and now I'm going to add just the numbers. Okay, so we can combine those into one. We've got 4a plus 2b plus c. Okay, all right. Okay, I lied. I am going to go back and do something to the left side. Okay, the left side is just a 2x. Okay, that is 0 times x squared plus 2x plus 0. Okay, I'm just emphasizing here that the number in front of x squared is 0 and the constant term here is 0 on the left. Okay, at this point, we're going to equate things. Okay, because again, we're trying to solve for a, b, and c. Okay, so what we're going to conclude here on both sides of the equation, okay, the number in front of x squared has to be equaled. Okay, so we're going to conclude that a plus b must add up to 0. And then the numbers in front of x must equal. So 4a plus 3b plus c has to equal 2. Okay, so 4a plus 3b plus c has to equal 2. And then lastly, all of the constants have to equal. Okay, so let me see. We'll use a different color here. We know that the 4a plus 2b plus c has to equal 0 because the constant is 0 on the left side. Okay, so let me write this out. Okay, so we're going to get 4a plus 2b plus c has to equal 0. Okay, this gives me a system of equations that I can solve for a, b, and c. Okay, this is going to take some room, so I'm going to move to the next page and start writing these equations down. Okay, so I've got a plus b has to equal 0. Okay, and then I've got 4a, 3b plus c has to equal 2. And then 4a, 2b, c. I'm just copying these down because I'm going to need some room to work. This has to equal 0. All right, so this is a system of equations. This time we have 3 variables and 3 equations. Okay, when you have something this size, you usually do matrices to solve, but you may not remember how to do that. If you want to go the matrix route, in the case that you do remember how to handle matrices, you are welcome to do that. I'm going to stick with elimination and substitution to solve this, okay, because we don't have it's a whole nother process to get into matrices. Okay, so here we go. I'm going to label these guys. So let's say this is equation 1, this is equation 2, this is equation 3. Okay, again, we're trying to figure out what is the a, what is the b, what is the c. Okay, all right, if I look at this very first equation, a has to equal b. Okay, so if you subtract one of the variables, move it to the other side. If I subtract off the b, for example, this is going to tell me that a is the same thing as negative b. Okay, so everywhere you see an a, you can replace it with negative b. Okay, so I'm going to do that in the second and third equations. Okay, so equation 2 is going to tell me that if I have 4a plus 3b plus c is equal to 2, I know that a is the same thing as negative b. Okay, so this is going to be 4 times a is the same thing as negative b, so you're making that substitution, plus 3b plus c is equal to 2. Okay, if I clean this up, I'm going to get negative 4b plus 3b plus c is equal to 2. And I can combine the b terms. Negative 4b plus 3b is negative b plus c is equal to 2. Okay, so it's kind of getting a little simpler. So I just made a substitution. I plugged in a equals negative b into the second equation. I'm going to do the same thing to the third equation. We have 4a plus 2b plus c is equal to 0. I'm going to replace a with negative b and then just simplify. Okay, this is going to tell me negative 4b plus 2b plus c has to equal 0. If I combine the b's, negative 4b plus 2b is going to give me negative 2b plus c is equal to 0. Okay? All right, so at this point, I am left with two equations and two variables. Okay? So I'm going to be able to solve this for one of these guys. Okay? So what I'm going to do now is I'm going to line them up. I have negative b plus c is equal to 2. And I have negative 2b plus c is equal to 0. Okay, we can do elimination on this. Okay, we need to adjust the coefficients for one of the equations, okay, and then add them up. Notice I have a c and a c. If one of those c's were negative, they would cancel. Okay, so what I'm going to do is multiply the first equation by negative 1. Okay, you could have done it to the second. Okay, there's lots of ways to do these solutions. Okay, so this is going to tell me if I multiply the first equation by negative 1, I'm going to get, you've got to send it through everything here. Okay, so this is going to be positive b minus c is equal to negative 2. I'm going to leave the second equation alone, negative 2b plus c is equal to 0. And now I'm going to add b plus a negative 2b is going to be minus b. C, negative c plus c, those guys cancel. And then that's going to equal to negative 2 plus 0, which is negative 2. If I want b, I just have to divide by negative 1. So we're going to get that the b value here is positive 2. Okay, so that's one of the coefficients, which is super duper that we have that. Okay. At this point, it's really easy to get c. Okay, we know how b and c are related. We know this yellow equation that negative b plus c has to equal 2. We know that negative 2b plus c has to equal 0. It's got to abide by both of them, but to get the value, just pick one and plug it in. I'll go with the first one, but you could definitely choose the other yellow equation. Okay, so negative b plus c has to equal 2. Okay, I know b is positive 2. Okay, so be careful here. This negative sign is going down here. Then you're going to replace b with positive 2 plus c has to equal 2. Okay, this allows us to solve for c, so I'm going to add 2 to both sides. This is going to tell me that the c value has to be 4. Okay, so we're almost done. We just need the a value. Okay, so here we go. Going back up, what do we know about a? Well, boom, we know this. Earlier when we were working with this, we know that a has to be equal to negative b. Okay, that has to be true. Okay, so what we're going to do here is I'm going to go ahead and write this down. Okay, so a has to equal negative b. Okay, so at this point, a has to equal, this negative sign is going to stay right here, and then I write down b is positive 2, so we get that the a value here is negative 2. Okay, so we've got the a, b, and the c. We can go back to the previous page, and we can write down the partial fraction decomposition. Okay, so if I go back to my original fraction, or my work, actually I'll go right here. Okay, when I set up the partial fraction decomposition. Okay, we just learned that a has to be negative 2. We also learned that b has to be positive 2. And we know that c has to be 4. Okay, so we can go ahead and write the final answer. Again, our goal was to take this original fraction 2x over x plus 1 times x plus 2 squared and write it as separate, simpler fractions that we are adding together. Okay, so follow the recipe that we have right here, and I'll even put it in the box here. So let me highlight this. Okay, so this is the guy we're looking at. Okay, we're going to follow this recipe and write down the partial fraction decomposition here. Okay, it's going to be a, which is negative 2 over x plus 1, plus b, which is positive 2 over x plus 2, plus c, which is 4 over x plus 2 quantity squared. Okay, this is the partial fraction decomposition. These are the 3 simpler fractions that you can add up, that when you add them up, you get the original single fraction. Remember, you can check yourself. You can take this answer in the red box. You can get a common denominator, add these 3 fractions and combine them into one and simplify. Okay, you should get what we started with, 2x over x plus 1 times x plus 2 squared.